ASTM C143 is the standard method of test for the slump of hydraulic cement concrete. Though many people use the slump to measure workability, the purpose of the slump is to measure the batch-to-batch consistency of the concrete. To perform this test, we will need a mold with a 4-inch opening at the top, an 8-inch opening at the bottom, be 12 inches in height, and be in the shape of the frustum of a cone. A tamping rod is also required. The tamping rod shall have a diameter of 5/8 of an inch, shall have a length at least 4 inches greater than the height of the mold, but the length shall not exceed 24 inches. And finally, at least one end of the tamping rod shall be rounded to a hemispherical tip of the same diameter. A measuring device, such as a measuring tape or a ruler. In any case, the measuring device shall be capable of measuring to within 1/4 of an inch. Depending upon our maximum aggregate size, we may need a 1-inch sieve, because the maximum aggregate size permissible in the slump test is 1.5 inches. If we have any aggregate larger than 1.5 inches, the sample will be wet sieved over the 1-inch sieve. And finally, we'll need a scoop. When performing the test, we want to set up the mold on a flat, level, moist, non-absorbent surface. Furthermore, we want to fill the mold in 3 equal layers according to volume, not the height of the cone. This means the first layer should fill the mold to 2 5/8 inches in height, the second layer 6 1/8 inches, and the third layer should fill the mold to the top. Each layer of concrete is rodded 25 times. The first layer throughout its entire depth without forcibly striking the base. The second layer is rodded throughout its depth, penetrating the previous layer by about 1 inch, and the third layer is also rodded throughout its depth, penetrating the second layer by approximately 1 inch. When lifting the mold, we want to lift the mold in 5 ± 2 seconds. We can then take our slump measurement. The measurement is taken from the top of the mold to the original displaced center. Let's now go through a detailed performance review of this procedure. First, a sample must be obtained in accordance with ASTM C142, standard practice for sampling freshly mixed concrete. Before we begin, we must inspect the interior of the slump cone, as the interior is not permitted to have minor irregularities. After inspecting the interior of the slump cone, we want to moisten all of our equipment. Then set up your equipment on a flat, level surface. We now want to stand firmly on the mold tabs and have the first layer of concrete introduced into the mold. This layer is now rodded 25 times throughout its depth without forcibly striking the base. We can now add the second layer of concrete, filling the mold to a height of 6 1/8 inches, and then, taking care to penetrate the previous layer by approximately 1 inch, rod this layer 25 times. Now add the third layer so that the concrete has completely filled the mold, and repeat the rodding procedure, taking care that you penetrate the previous layer by approximately 1 inch. Upon completion of rodding the third layer, we want to remove the excess concrete from the top of the mold by using our tamping rod in a rolling screeding motion. Before lifting the mold, we want to brush away any excess concrete that may be built up at the base of our mold. Now, maintaining downward pressure on the mold, we can step off the mold, then lift the mold in 5 ± 2 seconds. We now want to measure our slump from the top of the mold to the original displaced center to the nearest 1/4 inch. Note if there is any shearing or falling away of the concrete. The test must be discarded and repeated. Lastly, we want to record and report our final slump measurement to the nearest 1/4 of an inch. And a few final notes. First, the slump test must begin within 5 minutes after obtaining your sample. Next, the slump test must be completed from beginning to end within 2.5 minutes. And finally, steel rods are necessary in this procedure. Plastic rods are not permitted. And this will conclude ASTM C143 standard test method for slump of hydraulic cement concrete.